Hello everyone. I welcome you all to Startup Academy. This coaching exclusively for ISS exam. In the previous lectures, we have been covering the topic econometrics, and we have almost come to an end of this topic. Today is the last lecture of this topic, and most of you have been covering the same topic with us and asking your doubts on WhatsApp and in the comment section, which is commendable. I hope that you have covered almost all the topics with us, and if not, then start doing now because this requires a lot of time and a lot of effort. And without pen and paper, and by just seeing the video, you cannot do this. So, you have to do it on your own with our support. So, today is the last topic that we'll cover. Today's topic is Theil process. So this procedure was developed when we observed that when we take OLS estimators, the residuals in the OLS estimators are correlated with each other, and thereby we cannot find the residual correctly, or there is so much autocorrelation, and there is also heteroscedasticity in the model. So this procedure, when two of the limitations, we can say, when two of the limitations were get mixed, autocorrelation and heteroscedasticity in the OLS estimation residual, then then Henry Theil, who was a statistician in 1965, found out this procedure in which we convert our model into uncorrelated residuals and homoscedastic model, and thereby we calculate the estimates, and after that the same procedure is followed. So this procedure is known as Thiel process. Now what is BLUS here? Best linear unbiased uh, scalar. So whenever our model has correlated correlated residuals and error are heteroscedastic. We use Thiel process. It was founded by Henry, or invented by Henry Thiel in 1965, and hence it is known as Thiel process. BLUS is best linear unbiased scalar, or this can be written as BLUSP, BLUS, where P stands for procedure, as we all can see. So, what is the idea behind this? If we have been given a model y is equals to x beta plus epsilon for all epsilon belongs to normal 0 comma sigma square I. Now here, if we calculate our estimation of this, if epsilon is nothing but my, then we can get the variance of epsilon is nothing but I minus x dash x inverse x. Here we can see that variance is not or variance is not equal to sigma square I, and hence not homoscedastic, and hence we can write it is heteroscedastic. Although epsilon, which is the error term, is is the uh, is the linear pair of y, still we cannot say that it is homoscedastic, it is heteroscedastic. And the other thing is they all are correlated. Residuals are correlated with each other. Hence, our problem arises. And for solving this problem, we will put the method, we will substitute this model. We will substitute this model with another error term, mu. Let us take mu. And then after that, that mu will estimation of that mu will be 0, and variance of mu, that mu will be sigma square I. So what do we do? That we have, suppose we have n number of observation, and out of n number of observations we will take out k number of observation that are correlated. So we are left with n minus k number of observation. Those n minus k number of observation we will take it in the model, and we will leave the k observations which are correlated, the uncorrelated we will take, and we'll form a model with them. And hence our all residual terms are now uncorrelated, and our variances are also homoscedastic. So hence we have formed a new model which is uncorrelated linear pair of y and this homoscedastic. So hence we have solved this procedure by Theil process. So we can write it as, let us k take out k correlated observations. We are left with n minus k observations. Simply, now we'll form another model. Suppose our model is y dash is equals to x dash beta plus f mu dash. Here mu dash, estimation of mu dash is equals to 0, and variance of mu dash is equals to sigma square I, where I is n minus 1 of the, where I is of the order n minus k. So here we will get our estimation of beta cap by OLS estimation method, and hence we'll get all the values. Here our model is homoscedastic. And the residual, which is epsilon dash epsilon, is also uncorrelated, which means that covariance of EI EJ is equals to 0. And hence by Theil process we have solved our problem. But this problem has been, this problem can be used differently. It has limitations as well as advantages. The limitations of these processes, only n minus k observations are taken, not whole of the model. So k observations are ignored, and this may be very difficult for a sample which is very small in number. Suppose we have a sample of 10 numbers, so we will take out 9 observation and we are only left with 1, because 9 observations were correlated. So it becomes very difficult for us for a small number of sample. And moreover, this process has now become deplete, because this process is replaced by cum sum process, cumulative sum process, Q tests, and many more tests, which are more modern techniques of solving this kind of problem as compared to Theil process. So in advantages we can write, sorry, limitations. First limitation is k observations are ignored, which might affect small samples. As I've told you, that if you take 10 models and out of 10, 10 sample, and out of 10 only 9, all 9 are correlated and one is uncorrelated, then we have to get rid of all 9 samples, or we can get rid of 8 out of 9, so that both the two remaining observations are uncorrelated. Or the second one is, it this procedure is replaced by new methods like cumulative sum or Q tests, etc. So these were your disadvantages. Now what are the advantages? So in autocorrelation, we have done one Durbin-Watson procedure. So this procedure is helpful in Durbin-Watson procedure. It helps in testing autocorrelation. One advantage is this: it helps in the testing of heteroscedasticity also. And the second most important advantage of this process is this is helpful in the model, in model prediction or in model checking, since all the residuals are uncorrelated, and it is easier to analyze uncorrelated residual as compared to correlated residuals. So first advantage is that helpful in Durbin Watson autocorrelation test procedure. And second advantage is that it is easier to analyze uncorrelated residuals as compared to correlated residuals. So this completes your course of econometrics. Let us see what all we have covered, and I don't think anything is left. So let us open the. Okay. So nature of econometrics and the general linear model and its extension. All of the general linear model is multiple linear model. Firstly, we have done simple linear model and then general linear model or multiple linear model. All of this we have done. Then OLS, ordinary least square, for both general linear model and its prediction. Predictions included your confidence interval, unbiasedness, variance, and testing of hypothesis. Then generalized least square is used for general linear model, which is nothing but OLS of multiple linear model. Then estimation and prediction of this as well we have done. Then heteroscedastic disturbances, pure and mixed estimation. Also this we have done, pure estimation and mixed estimation when we mix two models. Now this is the limitation of Gauss-Markov theorem. autocorrelation, consequences and test, Theil plus process. Today we have completed this only, and its estimation and prediction of this autocorrelation model. We have completed an autocorrelation class only. Now, multicollinearity problem, its implication, tools for handling the problem, and ridge regression. The problem of multicollinearity, its implications, and all the tests including that, and all the processes by which we can simplify multicollinearity. Also we have done, ridge regression is one of them. This also we have covered, and we have covered a question pyq based on this topic as well. Then linear regression and stochastic regression. Linear regression is simple linear regression model, and stochastic regression is all those models which come under linear regression. Then instrumental variable estimation, this also we have done, and we have covered a pyq also of this. Errors in the variables also we have done with instrumental variables. Autoregressive linear regression, lagged variables, distributed lagged variables, estimated of lags by OLS method, and Kochek's geometric lag model. All of this we had covered in one lecture of our econometric series, and this was all have we have also covered one pyq on that. And I have also told you how to write them in the exam. They are asked in the exam, but not on numerical form, on the way on theoretical form, and I have told you with example how to write them. Then simultaneous linear equation model, SEM, and its generalization, identification problem, restriction on structural parameter, rank and order condition. Or we have been doing covering SEM and its identification problem, whether it's identifiable or not identifiable, over identified or under identified, all of them. Then rank and order condition, this also we have covered. Now estimation of SEM, this also we have covered. Recursive systems of model also we have covered. What are the recursive system of models? 2 SLS estimation, limited information estimators, and K class estimation, 3 SLS estimators. This also we have covered in one lecture of our topic. Full information maximum likelihood also we have covered, and prediction and simultaneous confidence interval in the last lecture we have covered this. This hasn't come yet in the exam, but this can come. This can become in this time, or maybe this can be asked for 10 marks. So I have told you exactly how to write them. It is a very easy topic. So this completes your topic econometrics. We are done with econometrics. Now from tomorrow on, we will start with another topic. If you have any doubt, or if you think that we haven't covered any topic correctly, or we haven't covered any, we are left with any topic, then you can ask in the comment section, and you can tell us where are we lacking. And tomorrow we will start with sampling, which is the paper 3, which is paper 3 only, and it also has a vast syllabus. This is your sampling techniques, and it is one of the most important topic in paper 3 as well as for your examination. Firstly, we'll cover all large topics like sampling, econometrics, and rest other. Then we'll come to small topics, which are the basics. Firstly, we'll cover all the large ones that will be solving your basics as well as your major portion of the course. Then we will come to smaller topics that you will already know what all we have covered in basics. You will already know that we have covered in this major topics. So it will become easier for you to understand. I hope you got all we have done today. This completes your econometrics syllabus, and we'll do a class. We'll start a class on the next topic from tomorrow. Thank you.